Hello everyone. So today we will start a new stream of sessions that is based on Python. So in previous videos we have shown some of our Python tools and you guys have shown a lot of interest in those tools. So I thought we can do some sessions on Python, do some basics and then go on and show how we can make some basic 5G tools using Python programming. So for today, what we'll do is that we'll go through some basics about Python. We'll go write a basic code uh, showing how we can take input from the user. Then we will write another code showing how we can take input configuration for a 5G network and then give an output as a 5G throughput calculation. So let's start with that. Before this, if you're starting from the scratch, you need to know what you need to install. So if you do not have Python already, you can simply go to python.org/downloads, download the latest Python version. The installation is pretty simple. Once you download it, you can install that. And after this, in order to write the code, you need to have a text editor. So I usually use this one, atom.io. So you can just download that, and it's also pretty simple to install. So once you have downloaded both of them and installed both of them, and then you can open the Atom. It will look like something like this if you see on my taskbar. So let's say I open it here. So this is where I can write my Python program. So let's start with something simple. So let's say I do only a print, and I say welcome to our channel, right? So something simple as it is. Now it will not work until you have saved it as a Python file. So let's say we go there, we do save as test1.py. So when I do .py, now it will be saved as a Python file, and you will see now that the text editor has put blue color for print and green for the string. So now if you want to run this, you can simply go to the same directory in command prompt. So for instance, this is my command prompt. So I go to cd python cd script. This is where I saved this file. So this is where I go and I do py, then the file name test1.py. So it will print out welcome to our channel. So this is something simple. When you want to print out something in Python, you can simply print it like this. Now let's look at something more complex. So what we want is that we can take some input from the user as well to make it an interactive program. So for practical use cases, the users need to interact, right? So let's say if I do let's say x is equal to input. I want the user to enter a number, so I do enter a number. Okay, so as, and I want to see if that number is being saved in this x or not, so I can do print x. Okay, so let's see. I save it, Control S, and I go back to the command prompt, run it. Now it is saying enter a number, so I enter a number 5, and it prints over here number 5, which means that the x now holds the value of 5, right? So this is something that you can use for taking an input. Now if you have that, then you can do many actions on this number. For instance, I can make let's say product is equal to int of x. So I just use this number as an integer multiplied by int of x, and then I say print product. So now what should happen is that whatever number I have entered here, I should also see its square value, right? So if I enter 5, then 5 into 5 should be 25. So let's see now how it looks like. So this is it. It asks me enter a number. I enter 5. It says 25, right? Again, we can try another number. Let's say 9. Then it says 81 here. So this is how you can make take multiple actions on inputs as well. So let's say I want to take another number. Let's say y is equal to input, enter another number. and I want now the product should be of these two numbers, so I do int x into int y, right? Yes, and I don't really want to print it anymore, so I just put hashtag here, and that will then comment it out. It will not be part of the code anymore. I save it with Control S. I go back here. Here we go. So enter a number. Let the first number be 8. Let the second number be 5. The product is 40. So this is how it will show me that now the product of these two numbers is 40. Similarly, I can do a division is equal to int of x divided by int of y as print division. So now if I go back there, let's say my first number is 10, second number is 2. Now the product is 20, the division is 5. And let's see another number, let's say which are not exactly divisible. Let's say we do 54 and we do 11. So now we can see the product is 594 while the division is 4.9. So this is how we can do multiple iterations on them, and we can actually take a lot of actions on input from the user. Now another important thing would be that when you want to present it, you want like to have some text here, right? Because over here we know that this is product and this is division, but a user which is looking at the program for the first time will not know what is this, right? So it's good to put a message, and that's how usually it is done. So we can put a message here, the product is, and then when you put the product itself, then you can put it as a string value, because when you concatenate one string with another, you need to put a string. So I am now putting product as a string. str makes it a string. So let's see how it looks like now. So we do the same thing, 10, 5. So the product is 50, right? So this is how we can put some values and also put some text together to show the user what is the output. Okay, so now if this is clear, now it is something simple. So let's see how we can calculate 5G throughput. So if you remember, I have done a video on 5G throughput before, a video session on that, and if you have understood that, then it will be easy for you to make a code. So for any kind of tool that you want to make, you need to know Python, but you also need to know 5G or LTE theory as well, right? Only then you can make it make sure that you get an output that is practical. So so let's say even if we use the same one, I can just remove all of this, and now what is the first thing I want from a user? I want to know what is your 5G bandwidth, right? So input 1 is equal to input, enter the 5G channel bandwidth, right? And what is the next thing we want to know? We want to know the subcarrier spacing, right? So input, enter the subcarrier spacing. Okay, we should also put the units, because some people might put it as kilohertz, then our algorithm will not work properly. Similarly over here we want this to be in kilohertz, so we put kilohertz here, right? So that will actually ensure that the input is from all the users is consistent, so then our algorithm will be consistent as well. Another thing we want to know would be the number of MIMO layers, right? So enter the number of MIMO layers. Okay, so now we will have input 1 will carry the bandwidth, input 2 will carry the subcarrier spacing, input 3 will carry the MIMO layers. Okay, so now we have that. Now the next thing we need to know, we need to find out the number of resource blocks available. So how do we do that? If you remember, one resource block is actually carries 12 subcarriers, right? And we find out that the spacing of each will be from this input. So the actual resource block count will be let's say we can say x is equal to, so this is the bandwidth which is in megahertz, right? Now in order to convert it to resource blocks, because this is in kilohertz, so we multiply this with to 1000, that will make it into kilohertz. Then we divide it by the subcarrier spacing, int input 2, and then because we know that in one resource block there are 12 subcarriers, so we also divide it by 12. Now this will give us the number of possible resource blocks available in this channel bandwidth. But we know that there is a guard band usually, which will normally 2 PRBs on top and 2 PRBs on bottom. So the number of PRBs will be is equal to x minus 4. So this will be usually the correct value of number of PRBs, and I can do print num PRBs, and let's see. So let's run this code for now and see how it looks like. So it says enter the channel bandwidth. Let's say I say 100 megahertz. Then it says enter the subcarrier spacing, it is 30 kilohertz, let's say. Now it says enter the number of MIMO layers. Let's say we say it's 4. So the number of PRBs it says is 273.77. Now the number of PRBs is this, but usually it is the value should be discrete number. It should not be something in decimal. So how do we change that? We can floor this to 273. So how do we do that? We can do it like this. Num PRBs is equal to, now in order to floor it, we can use the math function, math.floor num PRBs. Now if we do that, we also need to include this in the program so that the system knows where to get this function from. So we put import math. So this is what will import math, and then we can use it. So now let's see how it looks like. See, now it is 273. So we got the exact value of number of PRBs from here. Now if you remember that session that I discussed about, let me go back to that quickly just to reiterate. So from there we found out that this is, let's say, 1 PRB, and this is the number of symbols, and from here we found out how many symbols will be there for data, and then we multiplied with the 3GPP maximum spectral efficiency from this table, and we got out this value, 977 bits. So this is the one that we got for 1 PRB. So when we need to multiply and convert it into throughput, what we do, we multiply this one into number of PRBs into number of slots and into number of MIMO layers. That is what gives us our throughput. So now this is something that we already know what it is. So throughput will be (977) multiplied by num PRBs. So I can do num PRBs multiplied by DL slots. Now okay, we need to put that as well. So let's say we call it DL slots is equal to 1600. Now when you are using 4:1, 4 downlink, 1 uplink, this is the number of slots you will have in 1 second for downlink. So you can do this int DL slots, and also we also got the number of MIMO layers from the user here, input 3. So we can say input 3, that is there as well now, right? So this is all our number of bits per RB into number of RBs into number of slots per second into number of MIMO layers, and then we need to convert it to Mbps because this is in bits per second. So this will be our throughput. So if I now print this, so let's see how this looks like. So I do 100, 34. So this is my throughput now, 1707. Now again, as I said before, we need to put some text before that to make sure that we understand what is the output. So we can, let's do it over here as well. Available number of PRBs is, and similarly over here we can say maximum throughput for this configuration is, and we need to convert it to string because it is a concatenation of two strings. Similarly here as well. Here you go. Okay, let's see how this looks like now. So we put 100 megahertz, 30 kilohertz. Sorry. So now we have available number of PRBs as 273. Maximum throughput for this configuration is 1707 Mbps, that is 1.7 Gbps. So now let's have a look at another configuration. Let's say I say my bandwidth is not 100 megahertz, it is 60 megahertz. The subcarrier spacing is still 30. MIMO layers is still the best possible, 4. So now you see number of PRBs are now 162. So they have gone down, right? And the throughput is also lesser now because I have a lesser bandwidth, so 1.01 Gbps. Similarly, if I use the same configuration, let's say 60 megahertz, 30 kilohertz, and I say MIMO layers are not 4 but 2 only, so we will see that number of PRBs are still same, 162, but the throughput is now half, for 1012 to 506 Mbps, because the rank, the MIMO layers have gone down to half, right? So this is something, a basic calculator that we can do. So I'm taking inputs from the user itself, and based on those inputs we are calculating an output, which is a throughput output, number of resource blocks output. So I hope this makes you understand what we can do with Python on the basic level. This is something practical. Of course, there are many Python courses which you can go and discuss about arrays and lists and dictionaries and everything. But I just want to show you something that is more practical. That is something that you can use for yourself to create your own 5G simulations, 5G tools, your own automation. So this is the first one. As we go on, we'll talk about more 5G things that we can automate or we can use Python to make. Then we will talk about the graphical user interface, like the tools that I showed you in other videos, which were more related to GUI level things. So we will talk about those as well and see how we can build our own GUI or our own graphical user interface using Python. So I hope you like it. If you do, please subscribe. Let us know that you like it, and we will continue doing this. That's all for today. Thank you so much. Have a nice day.